How's it going, algebraic reasoning students? It's Wednesday, test review day. Something came up. Sorry, guys. Man, I really wanted to be there today. You guys know I hate missing. But thought I'd make this for you guys. I'm at home now. I'm not just sitting here on my lunch, so I won't have to rush this time. Hey, look at this guy. Okay. Sorry about the black space above me here. Here it is. Literally can't even. I don't know. I thought of thinking of something clever to put there. I got nothing. Give me some suggestions for the next one. Okay, I'll think of something. Also, my lighting is so awesome. Look, hey, there's my ceiling fan over there. Okay, so I'm doing awesome right now. Okay, but hey, let's get a video going for you guys. Let's start reviewing this stuff. Okay, this is gonna be important. We're still gonna have that test on Thursday. Okay, so make sure we're paying attention. We're not just pausing and then oh yeah, half paying attention. All right, yeah, and then writing down the answers. This is about the process. This is about how it works. Remember, my reviews very much like my tests. Okay, they're almost identical, just with different numbers. So again, that's the process. It's not just about these answers, okay? So knowing how to do it. You guys are actually, I know some of y'all are going to ask me questions probably when we show up on Thursday or something. And that's good because you're thinking about process, and that's great. This first section right here, we're literally, let's read it. What am I doing? Why would I guess? Let's read it. Oh, way bright. Too bright. Oh, not bright enough. Okay, all right, we're just going to deal with it. Okay, find the function equations that represent each set of linear data. Here's our key word here, linear. It tells us they're all linear. We don't have to figure it out. We don't have to do first differences. We don't have to do anything like that. My biggest thing here, these are calculator, man. Calculator. Okay, these are calculator problems. Okay, they're just giving us some tables. We know it told us they're linear, so we know to use linreg, so we're good to go. All right. Hey, I'll do a couple examples. I'm not going to do all of these. Just because, that's, you guys can figure this stuff out. That's not too bad. Okay. Let's see. Let's at least frame what I do on here. Stat. Okay, remember stat. And then we just hit enter. Stat and enter. Bingo. X is over here. Y is over here. Okay, so it goes 0, 1, 2, 3, 4. Just like that. Okay, and then over here, a bunch of 5s. Interesting. 5, 5, 5, 5. 5. Always good to check your table, okay? That was coming up in our assessment yesterday too. A couple people, they mistyped something and then that gave them a weird equation. We're not gonna have weird equations here. They should be pretty straightforward. So if you get something really weird with a weird decimal, maybe double check your table, okay? 0, 1, 2, 3, 4, 5s. Okay, perfect. When we're done, we hit stat again. Okay, we hit stat again. We go calc, go down to linreg because it told us they were linear. We already knew they were linear. Enter. There we go. Y equals ax plus b, where a is 0, b is 5. So when I'm ready to change my slope, 0. Okay. When something's 0 from these equations like this, oh, they already gave us a y equals. We can write 0x or put the 0 where it goes, or not. It actually doesn't matter because when something's 0, it kind of goes away. But sometimes I like writing it because then it's oh yeah, okay, that's what was supposed to go there. Because sometimes when you don't write things, they don't look right. They look weird. So I like kind of putting it as a placeholder. Either way works. I'll take either one. There we go. There's another one. Let's just go through the motions again. Frame the buttons. Okay. Stat, enter. Now we got to put in different stuff. It's 0, then 2. So I got to be careful here. 4, 6, 8. All right. There we go. And then all my y values. I got -8. And again, make sure you put -8. You put -8, it's gonna freak out. Remember, negative is this guy. The minus is on the side. -8. Okay, use the negative button. -4, 0, 4, and 8. Okay, so there we go. Perfect. It's in there. We'll hit stat again. Remember, it's arrow to the right. Option number 4. Enter, and then off we go. There it is. Y equals 2x minus 8. Okay, so y equals 2x minus 8. I'm going to write it just like that. And that's perfect. Okay, I'll leave a couple for you guys. You guys can test those out. See what you get. Okay, some good practice for you guys. You guys can do that on your own. We've been doing that since the beginning of the year. Okay, Let's look at this next section. Lots of words. Look at all these words. What's with all these words? Goodness gracious. Let's dissect this. So determine if the data shown can be represented by a linear, quadratic, cubic, or exponential function. Here we go. This we've seen before. It's been a little bit. Linear. Remember, that's our first difference. Quadratic is the second. Cubic is the third. Expo is a multiply pattern. Okay? So if the pattern is a first difference constant, we're linear. Second, quadratic. Third is cubic. Exponential function will be a multiply. Okay? So that would be the first thing we're looking for, is looking for those differences. Next, if the function is linear or quadratic, determine the equation using finite differences. These equations will not be in the equation bank. Okay? So linear or quadratic, here's our equation bank. Not going to be down there. Okay? If the function is cubic or exponential, match it to one of the equations from our equation bank. I don't see an exponential function down there. Weird. Oh well, we'll figure it out. We'll make it work. We're smart people. We'll figure it out. Okay, so let's look at number one. Look at those first differences. Okay, remember, if you're trying to find those differences, differences between things, take one of these here, so 17, and we'll subtract the one right before it, so it'll be 8. 17 minus 8 is 9, so plus 9. Okay, I'm going to keep doing that on my calculator here. So that's, clear. 32 minus 17, you're 15. Oh, already we know it's not linear. Okay, first difference isn't constant, so not linear. 53 minus 32, that's plus 21. Let's see, 80 minus 53, we got 27 plus 27. Okay, 113 minus 80 is 33. Oh, plus 33, there we go. I think I draw too many of those little things. 152 minus 113. Goodness gracious, these are big numbers. All right, plus 39. So again, we're just reiterating here, definitely not linear. Okay, let's look at that second difference. Okay, from 9 to 15. So 15 minus 9 plus 6. Okay, from 15 to 21. That's actually also plus 6. Ooh, quadratic incoming. 21 to 27 plus 6. 27 to 33 plus 6. 33 to 39 plus 6. Second difference is good. Makes this a quadratic, or quad. Okay, so that's a quadratic. But then the next part underneath it says we want the equation. So what we need to do, now that we know this is quadratic, what we can do is we can type in our table into our calculator the way we've done before. Okay, but then this time we are going to pick quadratic instead. 1, 2, 3, 4, 5, 6, 7. Over here. 8, 17, 32, 53, 80, 113, 152. Oh gosh, I missed something. Oh no. Yeah, we're not lined up. Oh, poop. 8. See, this is why you check. 17, 32, 53, 80, 113. This is the worst part. All right, there we go. And then I got to delete the one that was before it. Okay, that looks good now. That looks much better. Okay, stat, calc. Now we're picking option 5 since it's a quadrag. Okay, quadrag. What do we got? So we got A is 3, B is 0, and C is 5. So that means we will have y equals 3x squared plus 0x plus 5. Again, we got a 0 in there. I could have left that out. I could have just said 3x squared plus 5 and life would have been good. But I like to put in those placeholders. All right, I'm a little extra. Y'all know. Okay, so let's look at the next one. Check this out. Notice something with me, guys. 2 is the top part. Look at that bottom number. 2048. We go all the way from 2 to 2048 in like a couple of steps, that should be like big old red flag, like expo. Okay, like exponential. Okay, this is gonna be an exponential function for sure. Okay, so instead of it being a plus or a minus, so we're looking at differences. Instead, what are we multiplying by? All right, because I mean, you might as well check if things get big super fast like that. You might as well be checking if it's expo. Okay, so times what? 2 times 4 makes 8. Okay. 8 times 4 makes 32. This is looking promising. But then now I'm here. I get to this one, 128, 32. I don't know. I can't do that one in my head. So how do we figure that out? Well, how do we figure out what this is going to be? Well, I'm so glad you asked. Right here. Okay. We can always check a multiply pattern similar to the way we do an add or subtract pattern. We can take one of these numbers here. So like 128. I think that's the one we're stuck on. Okay. 128, and we'll divide it by the one right before it. Okay, we spend a little bit of time on this semester, or this unit. Okay, so we'll take one of these numbers, divide it by the one right before it. 4. So that's what we multiply. Oh gosh, you can't see that at all. Boy, my lighting is just awesome today. All right, so 4. All right, so that means that this is a times 4. Okay, we continue that. I do 512 divided by 128. Lo and behold, it's 4 again. So we're multiplying by 4. 512, okay, times 4. Let's just try the pattern out. Times 4 this time. Hey, it's 2048. That is an exponential function. Absolutely through and through. This is an expo. For sure. Okay. But then it's like, hey, exponentials has x as the exponent. So looking at my equation bank, I'm pretty sure my instructions were lying. That's definitely they're lying right now. Okay, that's not cool. Not cool, Robert Frost. Okay, so let's do something else. I don't know. I honestly, I'm gonna be 100%. I don't remember if I've shown you this or not. But you know what? We're smart enough to be able to figure it out. So let's do stat, enter. Okay, make sure we're doing this right. 0, 1, 2, 3, 4, 5. I'll delete that. Come over here. We got, what is that? 2, 8, 32. What else we got? 128, 512. And then there's a huge one, 2048, and then we want to delete the one right before that. Check it out. So we put that table in there. We get stat, calc. Now I'm seeing a cubic reg, a quad reg, a lin reg, but man, what we're looking for expo. Oh, exp reg. Okay, they're leaving out the O. We can always do that. Check it out. Exp reg. Okay, there we go. It's done. Okay, y equals a times b raised to the x. So a is 2, b is 4. So what does that look like? Y equals, am I even on frame? I'm not. Gosh, I'm doing awesome right now. 2 times 4 to the x power. Okay, that's what that looks like. Okay. That little, I call it the little caret. Little caret's just saying what's the exponent. Okay, so my exponent's actually the x itself. All right, so that's how that would look. Okay, I'm gonna take a guess here. I'm gonna take a big old guess that this is linear, and I bet I'm right. Plus 5, plus 5, plus 5, plus 5, plus 5. Hey, look at that! I was right. This is the first difference, which means that we're linear. So this is gonna be linear. It's linear. And remember, we had a little shortcut. We had a little shortcut for figuring that out. I mean, that's a lot of things to type into the calculator. So how about let's look at the shortcut this time. Remember, we had y equals, and then it was supposed to be y equals mx plus b. So we had the slope, and we had our starting point of that y-intercept. Well, the y-intercept, ooh, we don't see it. Y-intercept, we'd have to kind of go backwards on our table. Ooh, I'm getting all advanced now. This is not good. So that has to be plus 5. So 8 plus 5 would be 13. And then 0, 3. Okay, maybe I shouldn't have done this. I immediately regret this decision. Y-intercept is 3. The slope is change in y over the change in x. Well, our change in x is 1, so that's 5 divided by 1, which is 5. Just plug it in the calculator if you want to, okay? You're like, oh gosh, Podman, what did you do? You're confusing me. Plug it in the calculator, okay? If that was confusing, just use the calculator, all right? What does that leave? What do we got left? Quad, expo, linear. What's this got to be? What does it got to be? What's it got to be? Cubic. Okay, cubic. No need to find an equation for cubic. It's complicated. It's weird. I mean, you can do the cube reg thing. It's long. It's a lot of things to type. Or you can use the equation bank. Okay, so looking down here, equation bank. I got some options. Let's see. How do I check? Great question. Let's clear that. Instead of going to stats, let's try this. Let's go to y equals. What the heck did somebody type in here? What is that? See, like, this is why I like clearing the calculator. That was ridiculous. What was that? Let's try this first one. I don't know. It's right next to it. So let's try that one. We're just gonna plug it in y equals 3x raised to the here. Let's frame that again. 3x, and then there's my little caret, raised to the third power. Okay, there's another way you can do that too. If you know it, that's good for you. Minus 5. So there we go. 3x minus 5. Make sure this is a minus since it's in between two things. Oh gosh. Sorry. Okay, so that's typed in. Let's look at the table. Okay, what we're looking for is matching table. Okay, matching table over here. We want these tables to match. This one, if we look, 2 for x, y is 19, y is 43 on this one. So right now, this is the one I typed in. I'm going to cross you out. Can't be you. Sorry. Bye-bye. Okay, let's try something else. I don't know. I'm going to be 100%. I don't know what the answer to this is. We're going to find out together. We'll see if it's the one on the left. Let's try door number 1. Only difference is this is a 2 instead of a 3. So let's just put 2 because we already got the x cubed. Got the minus 5 in there. Let's just try it. Oh, I just tapped my mic. Oops. Second graph. Let's look at those tables. Okay, we want to compare those tables over here. I got 2, 11. No bueno. Nope. That didn't happen. Nope. Wasn't that one. Right? And we already got something that's wrong. Something that didn't match. That only leaves one option. Y equals 5x cubed plus 3. But hey, you guys know me. I'm not just going to assume that's the answer. I'm going to check. What if there's a typo? I don't know. I'm already anticipating the complaining. Plus 3. So 5x cubed plus 3. Second graph. Okay. 243. 243. 3, 138. Or wait. 3, 138. 4, 323. 5, 628. All right. Yeah, I'm convinced. I'm convinced. This is the one. Okay. We just match the tables. All right. Match the tables. Okay. There you go. There you go. This already feels like this is kind of long. Is this long? I don't know. Okay. Situation. Okay, awesome. I'm so glad this came up. Okay, situation. We've got a male's heart rate depends on his age. The table shows the heart rate R for N years. What is the dependent variable in the situation? Guys, look at the first sentence. Look at the first sentence. A male's heart rate depends on his age. It literally says that his heart rate depends on his age. So which one's dependent? Heart rate. Okay. What's another way we could have known this? Well, X goes on the left, Y on the right. Dependent is the Y variable. Okay, it's the Y. So that's going to be the heart rate. Again, we got two ways of figuring that out. Okay. Write the equation that represents the heart rate with the number of years old. Well, how do we go about doing that? Well, we can type in our function into the calculator. Let's see. Let's see if we got a consistent pattern here. Look at my x's. My x's is a weird pattern. It's a weird pattern. We're going plus 5, plus 10, plus 10, plus 10, plus 30. That's weird. What if we just looked here? at the plus 10s and the plus 10s? Right? What if we just looked at these three? Okay, see if those are consistent. So let's see, that's minus 10. That's again minus 10. That's looking pretty consistent to me. That's looking pretty linear of it to be consistent like that. Helps if you frame the thing, Podvin. There you go. Okay, so that's looking pretty linear. I would say that's linear, for sure. Okay, definitely. All right. How do we come up with an equation that's linear? Oh yeah, we plug it in. Stat, edit. Oh my gosh, I've done this so many times now. Let's see, 5, 10, 20, 30, 60, delete. Over here, 209, 204. This is a good special PSA announcement, public service announcement. Make sure you clear your calculator if things are being weird. Clear your calculator. If it's giving you weird errors, clear it. Try it again. Second plus 712. Clear it if you got weird stuff going on. Okay. Stat to the right. Linreg. Okay. Here we go. Y equals negative 1x plus 214. Boom. There's an equation. Perfect. What would you expect the heart rate to be for a male of 45 years old? 45 years old. Well, years, that's the x. So this is x for 45, and then we're looking for the y would be our answer. So, easiest way I know is to plug it in the calculator. I mean, why not? Negative 1x, and then plus 214. Okay. Second graph takes us to our table. We want where x is 45. Now I can arrow down to 45, or I can do second table, type in 45, second table, go back, and then, hey, look at that, 169 right there. 169. Okay. How old would you expect someone to be with a heart rate of 179? This time they gave us the heart rate, which is y, and then the x is what we're looking for. So the x is what we're looking for. 179. There's 169. Hey, we're already kind of close. 179 was 35 years old. Okay, so we want 35 years old. 35. Okay, for being really, maybe I should, what do we say, beats per minute? I don't know if you guys know what that is or not. I don't know. Whatever. It's not a big deal. This is like years old. Did I lose my mic? No, it's good. Okay. Gosh, I'm nervous. All right. Table shows the distance traveled by a car as it starts accelerating. Okay, so we got a car that's accelerating. We got time, T, distance, D, over time. Okay. What is the independent variable in this situation? So that's usually the X. The only problem is this table's not how we usually see it. Okay. But normally when they're on their side like this, it's X on top and Y on bottom. But also, if you guys remember, our example for an independent variable was time. It literally, that's the one that I used as the quintessential example, the best example. Time. Okay, time doesn't care. It's independent. It just goes. Time goes and rolls and keeps going and goes even further. Okay. Which of the following equations best represents the situation? I mean, we could go through and figure out with the difference tables, all that good stuff, figure out what type it is, type it in, whatever. Forget that. You got equations right in front of you, right here, guys. Type them in, try them out. Put them into y equals 2.25. Instead of t, we'll just use x and then squared. There you go. Okay. All right. We just plug it in. Second graph. And then we're looking at, oh gosh, my table's in a weird spot. Back to 0 with you. Okay. We're looking for 0, 2.2. Oh, see. Oh, wait, no, 1. Oh, see, I got to check myself. 2.9. Yep, not quite. Not quite. It's 2.18. So, nope, can't be the first one. Cross you out. Okay. Let's try the next one. We had 2.25 just x, so not squared or anything. Let's see what happens there. 0, 0, that works. 2, 4.5. So no, we got worse. We got worse. Nope. Okay. How about this one? Y equals 4.5 x But then now that's cubed. That's to the third power, if you guys can see that. That's the third power, so I gotta raise to the third power. Second graph. Okay. 0, 0, good. 218. 236. Nope, can't be that one. Of course it's the one on the right. Of course it's the last one I try. Of course. Okay, y equals 4.5x squared this time. Okay, 0, 0, 218, looking good. 5, 112.5, and then 6, 162. Bingo. Okay, match the tables. Okay, we just match the tables up. All right. What or why does the ordered pair negative 218 not make sense for this situation? Why does it not make sense? It's an ordered pair. It's a point, right? It's a point. X, Y. Remember, so that negative 2 is X. That negative 2 is X. What do we know about negative time? Does negative time exist? X was time, right? We just talked about that. X is time. Can we have negative time? No, we can't have negative time. Of course. No negative time. Time only goes forward. Time doesn't go backwards. Okay, you got a time machine already. What are you doing here? Okay. Time doesn't give a crap. It moves forward. All right. Another situation. Carly has a $60 gift card, favorite tea shop. Every time she visits the tea shop, she gets the same drink for $3.50. Complete the table representing the amount she had remaining on her gift card after purchasing drinks. Okay, what they set up for us, again, it's a sideways table, so X is on top, Y is on bottom. That's good to remember. She starts with $60. So if she's bought no drinks, how much is she going to have? She's going to have $60. Okay, that's what's going to be on the gift card. If she buys one drink, she has $60 on that gift card. We got to take away $3.50. We're going to take away $3.50. She's got $56.50 left. 56.50. Okay. We get another drink minus another $3.50. Now she has $53 left on that gift card. Okay. To get another drink, another $3.50 gone. 49.5. This is just like the Sonic gift card thing. Minus another $3.50. We got $46 left. One more time. 46 minus 3.5. 42.50. Actually, let's make that money. Okay. So there we go. Write an equation that represents this situation. Well, since it's going down by a constant rate, okay, that's going to be linear. Okay, this is going to be linear. You can go ahead and plug that in the calculator. It's a linear function. Write it. Bingo. But let's remember how we did this by hand. Okay, we had that starting point. Our starting point was $60. That's what always goes on the end. That's not the changing thing. That's the constant thing. That's the constant. What changes, or what can change, is going to be that $3.50. Okay, that $3.50. That's going to be what changes every time. And now it's not going to be positive. It's going to be negative $3.50. See, I didn't leave myself enough room for that negative. It's negative $3.50 because we're taking it away. So this should be, let's write this a little bit better right here. Minus 350x plus 60. That looks much better than what I did before. Okay. So that's kind of the idea there. Which of the following would be the domain of the function? So that function has no restrictions. There's nothing stopping it. There's nothing stopping it at all. Okay. Domain is the x2, by the way. Okay. Domain is the x. So we can get rid of these two that are talking about y. Okay, because we're talking about x. But there's no restrictions. There's nothing stopping it. This says x has to be greater than 0. Okay, x can be less than 0. In the function, that makes sense. X can be less than 0. But in the situation, that's a little different. But we're talking about the function. We're talking about the function. So we want to say domain, you're going to be this thing right here. This thing right here, that means all real numbers. So it's like any possibility. Whereas this one's just saying, oh, it's only positive things. The function doesn't care. You buy 1,000 drinks, that's going to be way in the negatives. The function doesn't care. The function doesn't care. The calculator and the function, this is going to keep going. Whereas our situation, though, think about our situation. What would be the most appropriate domain for this situation? This situation, A, is discrete. Okay, we can only get like 0 drinks, 1 drink, 2 drink, 3 drink. Okay, it can't just be anything. Okay, this is going to be very specific. I just got super blurry. So we can get 0 drinks, we can get 1 drink, we can get 2 drinks. Okay. Okay, all the way up to what makes sense for this situation is we need to figure out when are we going to run out of money? When are we going to run money on the gift card? Because we got to know where this ends. Got to know where this ends. So what we can do is this. We can plug in that equation again. Negative 3.5x and then plus 60. We can do that. Let's look at the table. Where do we have 0 money? Where do we run out of money? Ooh, okay. Looks like we can get, see, right before we get 18 drinks. See, we're negative for the 18. We don't want negative, okay? We don't want negative money. We want where we have some money left over. We can get 17 drinks before that gift card runs out. So you can buy anywhere from 0, 1, 2, 3, all the way up to 17 drinks, and that's what makes sense for the situation, okay? What makes sense for this situation is that we can only buy specific numbers all the way up to 17, because then any less than that, or any more than that, we don't have any money left on our gift card, and that doesn't make any sense. Negative money on a gift card doesn't make any sense, okay? All right. Also, just this is discrete, okay? Just, I don't know, just throwing it out there. Last one. Oh my gosh, is that really the last one? Okay, good. Oh, this is long. Okay. The height of a football after it was kicked is shown and given by the equation. Hey, they gave us an equation. Oh, that's awesome. Oh, that's awesome. Okay, we gave us an equation. Complete the table and answer in the following questions. So if we need to complete the table, yes, we could probably pick points off of this graph and then plug them over here. But man, anytime I got an equation, I'm going to use that. I'm going to use that. Much more precise. Much more precise. Let's see, 30x minus 5x squared. Just like that. Okay. Second graph. Oof. Starting at 0, we have 0. So height of the ball is 0. Next, 25. What else we got? 2 is 40. 3 is 45. Then we're back to 40 again. And then we're back to 25 again. Yeah, it looks right. So there you go. Hey, we filled out the table. And then it says answer the following questions. So let's look. Which of the following is true for this situation? Discrete or continuous? I have 2 reasons. 2 whole reasons why this is continuous. It is continuous for the most obvious reason of it being a line. Okay, it's a connected line. It's not just a bunch of dots. It's not just a bunch of points that they gave us. Okay. Reason number 2. This is almost literally the example I did in class too. Remember when I was doing that in class? I was throwing my phone up into the air and then saying it was coming back down. This is essentially the same thing going on. You're kicking a football and it's going up in the air and then it's coming back down. Okay, it's continuous. You can measure that height whenever. You can measure that time whenever. You can pick it out. Okay, it doesn't just magically go, poof, I'm here, and then poof, I'm up here, and then poof, I'm back down. No, it's like it travels that distance that whole time. Okay, that's what makes that continuous. So, like I said, there's 2 reasons. Lastly, domain and range for the situation. Okay, careful. It says for the situation, not the function. Not the function, okay? We're going to get more into domain and range and what that means. But really what I'm focusing on here is, can you make that distinction? What makes sense for this situation? Okay? Remember, domain is the x's. Here are my x's down here. Range is the y's. Those are up here. So for my x's, the smallest one I have is 0. Okay? The biggest one I've got here is 6. Okay? So 0 seconds to 6 seconds. And then all the rest of my x's are in between. Okay, so we'll just write it kind of like that. Smallest to biggest. Okay, it goes from the smallest x to the biggest x. Okay, and then we got the range. Okay, range is just the same thing with the y's. Our smallest y would be 0, right? It's the ball's on the ground. Okay, then our biggest our biggest Y would be our biggest thing up here where it was 3 seconds. Well, that just so happened to be 45. We found that out earlier. So 45 is my biggest. And then Y goes in between. So it's kind of like that. Whoop. Just like that. Smallest to biggest for this situation. Okay, what makes sense? It doesn't make sense for the ball to like fly up into the air and then go into negative land. That doesn't make any sense. Okay, the ball doesn't like go embed itself into the ground and start burrowing down into the thing. No. It stops when it hits the ground again. Okay. Again, hopefully this helped. You guys know you can comment on the video if you got any questions for me. Last one I was pretty responsive. See you again on Tuesday. I don't know how to close these things. I literally got nothing. Like, comment, subscribe. I'm not doing this to be a YouTuber. This is for you guys.